Okay. And for a square matrix, this is true. Inverse of a matrix is equal to transpose of a matrix when you have a square matrix. Square matrix means n by n basically. 6 by 6, 10 by 10, it's a square matrix. Okay. Now let us try to understand a little about labeling these principal components. So you have all these are coefficients, right, or weights of your principal components. These are the principal components. Now if you look at the weights here, SAT score is negative, top 10 is negative, right? Acceptance and student faculty ratio is positive, these two are negative. So your SAT score, top 10, expenses, and graduation rate, all these are negative. What are positive? Acceptance and student faculty ratio. These two are positive. What does that mean? What does that indicate? Right? What we are trying to do is we are trying to bring back some explaining power. The moment you transform, this cannot be explained as your regression coefficient values because you've done some mathematical transformations, variance, covariance, and then got some kind of weights, right? So by looking at the this new column, if we can come to know about whether this column is positively or negatively contributing, then probably it makes sense. So look at this. So here we have negative and here we have positive. So what does that mean? This sign here, the negative sign here, gives you some idea, right? Gives you some idea that maybe the SAT score value is low, top 10 is less, expenses are low, and graduation rate is low. So these are influencing to a less extent, yeah, your principal component score. These are having less influence on your principal component score. Acceptance ratio and student faculty ratio are having high influence. So what kind of universities have this kind of behavior? Wherein SAT score will be less number of students who were in their top 10 in their school days have joined you, where the cost is less, number of students who graduate is less, acceptance ratio is very high because it's probably a government university or public university that we are speaking about, or a tier 3 university that we are speaking about, wherein the student faculty ratio is also very high. That means for too many students you have one faculty. So maybe now you can name this as tier 3 universities, and suddenly you have given a name to this principal component. So now the explaining power has come back, right? Now we can do a lot of meaningful things. This is how you can actually label and try to give meaningful insight. So one more thing is, if two of the weights have the same sign, positive sign, and if they have more or less the same value, then these two are probably contributing to the same extent. Maybe these two are contributing equally. And if any of the values are very less, for example, if this is 0, what does that indicate? This indicates that this is having absolutely no influence. No information is getting captured. And if a specific row, within a specific row, all the values are zeros, that means even in your original data set, there is nothing much that variable is capturing. So you can probably ignore that. Okay, so all these kind of inferences can be drawn the moment you look at this principal competence table. These are the kind of inferences that will give you real context to proceed further with your analysis. Think about your survey questions. Initially, when you perform survey, probably you have devised 200 survey questions. And you'll get responses to those questions. The moment you take those responses and try to do principal component analysis on top of that, if you feel that two questions have the same value and the same sign, that might give you an indication that these two survey questions are more or less capturing the same information. So when you conduct the survey next time, probably you will come up with better survey questions which are less in number and which captures information more accurately because you're not capturing the duplicate information. Look at the widespread possibility of implementing principal components.